Assalamu alaikum guys, welcome. This is Shahfahadkhan and now today we are starting out a new chapter called Methods of Purification and Analysis, or in your book it's also named as Separation and Purification Techniques. And let's get started. Alright, so now in this chapter, the very first thing that I'm going to do in this video is discuss with you a few very important terms. Okay, before I proceed on to the major topic, let's first discuss a few terms. Okay, so here we are. Okay, what is an atom? The very first definition that we need to know, atom. I'm assuming most of you might know what an atom is, but now the standard definition is written right over here. Okay, atom is the fundamental particle of an element. Okay, then what is an element? I'll tell you just in a bit. Of an element containing the same chemical properties as the element that, and this element as an element that takes part in a chemical reaction. The atom itself also takes part in a chemical reaction. Okay, there's a comma over here, that takes part in a chemical reaction. Okay, in a chemical reaction, the atom itself can also take part in a chemical reaction. So what are the two properties of an atom? What is an atom? Atom is basically, you can think of it this way: it is the smallest possible particle of an element. Element is a chemical substance that is very pure. Okay, the definition of element is also written over here: a chemical substance which is made up of only one type of atoms. Okay, if you've got the same type of atoms and they combine and form a substance, that substance is called an element. An element, by the way, is a very pure substance. Okay, element is very pure. So what is an atom? Atom is actually the building block of element. It is the fundamental particle of elements. Okay, and the atom also has the same chemical properties as the element. An atom takes part in the chemical reaction. These are the three basic properties of atoms that you must know. We will be talking about atoms in a lot more detail in the separate chapter called atomic structure, but over here for now, just remember what atom actually means. It is the fundamental particle of an element which contains the same chemical properties as the element itself. Chemical properties means the properties like reactions with other elements and all the chemical stuff that it can do. Okay, and it also takes part in the chemical reaction. Simple. So if the examiner asks you the definition of an atom, this is what you need to write down. And by the way, this is a definition taken from a marking scheme. Okay, so now, and by the way, this definition isn't asked that frequently, but still, to build up your basics, you should know it. Then coming to element. What is an element? Element, as I told you, it is a pure substance. The purest substance, the pure substance which is made up of only one type of atoms. Okay, for instance, I'll give you an example of oxygen gas. Oxygen, O2, is made up of only oxygen atoms. Okay, oxygen atoms. Oxygen atoms, they make up this oxygen gas. And oxygen atoms, since they are only one type of atoms, they collectively form this gas. That's why oxygen is an element, and these are oxygen atoms that make up oxygen. Okay, then coming to pure substance. What do we mean by pure substance in chemistry? In chemistry, well, in our everyday life, pure substance might be, if we talk about food industry, it might be a food which is not contaminated by other substances. Okay, but still, the term pure that we use in our daily life and the pure that we use over here, they differ widely. In chemistry, what we mean by pure substance is that a substance that is made up of only one type of element, okay, is called a pure substance. What is a pure substance? A substance made up of only one element. Okay, a substance made up of only one element which is not mixed with other substances or other elements. And the examples include all the elements that exist around us. All the elements are pure. Okay, they are not mixtures, they are not chemically combined with other elements. Well, actually, sorry, I shouldn't use the term chemically combined because that's a different definition. But for now, just remember that pure substance is any substance made up of only single element. Okay, so in other words, I'm saying that any element is a pure substance. Okay, and these are the examples. Hydrogen is an element, chlorine is an element, oxygen is an element, etc., etc. And by the way, elements, they exist in diatomic form. These gases exist as diatomic. Diatomic means having 2 atoms. Okay, now what is a mixture? This is the fourth definition that you must familiarize yourself with. Mixture is a combination of different elements which are not chemically combined. Remember, chemically combined. This is the key term over here. They are not chemically combined. Okay, they can be physically combined. Okay, they can be physically combined, but they must not be chemically combined. If they are chemically combined, what do we call such a substance? Having 2 or more elements which are chemically combined, that's the definition of a compound. Remember what compound is? Well, we'll be talking about that in a separate discussion when we'll be doing atoms and elements in a lot more detail. We'll also be talking about compounds and mixtures, but over here, just remember that mixture is a combination of different elements or different substances which are only physically combined and not chemically combined. Okay, just remember that. Then and I've given you a few examples. Such example of seawater. Seawater, this example is important. Why am I saying that? Because I've seen questions, your MCQs coming, in which you were asked to choose which of the following is a mixture. And the answer to that MCQ was seawater and air. Seawater is a mixture of salt and water and many other impurities. Okay, chloride is there, sodiums are there, and many other impurities are there in seawater. But in addition to that, air is also a mixture. Air is not an element. Okay, remember, air is a mixture. This air over here is a mixture. And why am I saying that? Because in air we've got oxygen, we've got nitrogen, we've got carbon dioxide, we've got many other gases, but they are not chemically combined with one another. We've got soot, we've got carbon particles, smoke, etc., but they are not chemically combined. That's why it's a mixture. So air and seawater, these typical examples are very important because these have been tested in the past papers as well. So seawater is a mixture, okay, and air is also a mixture of gases. And by the way, you should know the percentages of different gases present in air. Air is 78% nitrogen, 21% oxygen, and 0.04% carbon dioxide and other gases, etc. The remaining, this makes 99%, right? So the remaining 1% includes 0.4% carbon dioxide and other minor gases, noble gases. And by the way, in the noble gases, do you know what noble gases are? Noble gases are those gases which are present in the group 8 of periodic table. Okay, group 8 of periodic table, group 8 or group 0. And by the way, it's not written as 8, it's not written in this number, it's written in Roman numerical, group 8 of the periodic table. Okay, and in the elements of group 8 of the periodic table, they are inert gases, meaning they are very unreactive gases, and they are also called noble gases. And in the noble gases, the most common gas, the most common noble gas present in air is argon, A-R-G-O-N, argon. Okay, argon is present in the greatest concentration in air as compared to other noble gases. This was also an MCQ, and you must remember this as well. Okay, so this completes the important definitions and important key points. These percentages are important because you are asked the percentage of nitrogen in some places, you are asked the percentage of oxygen and carbon dioxide in some places, you are asked to identify them on graphs, etc., etc. Okay, and this actually completes the discussion for this video. And in the next video, we'll be talking about how to determine the impurity and purities of different substances, okay, in a mixture, in something. Okay, so see you in that video.